Right. Next up, we have a speaker who's got a topic which is quite a mouthful. So let's see how many of you can remember this when I say it loud, okay? And I'm going to make you repeat it back. The topic is Gen AI, advancements, pitfalls, and areas beyond neural networks. Now, I don't know if you can say it back to me. All right, guys, let's put your hand together for Kanchan Bhonde. She's the product strategy and head of Makers Lab, a unique thin lab in Tech Mahindra. She's passionate about research, innovation, and product development. Kanchan, over to you.
Thank you. Good morning, everyone. This is a very interesting topic. I think Gen AI has become the topic of the day because of ChatGPT and the way things have happened. So today's topic is very interesting. What I will do is I'll start with a very quick introduction of who we are, what kind of work we're doing, and then we'll delve directly into the topic. So we are basically part of Tech Mahindra, and we are called the Makers Lab, which is the innovation wing of Tech Mahindra. We are very open kind of environment. So in the sense, we work with the academia across the world, we work with the corporates, which are our customers, as well as our organization ourselves, and with governments across the world. And when you talk to Makers Lab, you see a lot of different stories, but I would just name a few firsts in the industry that we've been doing. So we are the only company who actually came up with a therapeutic molecule which could work against the virus, against the COVID virus. This started as an experiment in silico, as in we tried to assess which of the existing medicines would work against the COVID virus. And that was an AI-based research which eventually led us to finding one therapeutic molecule which could work against the virus. We have also gone into a lot of weather prediction kind of work, and this is again a very interesting research which looks at ancient Indian knowledge, which is the Panchang, and identifies ways in which you could do a long-term weather prediction, especially on the rainfall side. And we published a paper on this on the Indian Journal of Science and Technology, where it is proven that for longer duration, as in for the next 2 months, for the next 4 months, 6 months, and so on, the ancient Indian knowledge, which is based on Panchang and planetary positions, is giving you a very good accuracy as compared to what you get from the weather prediction systems of today. So this is again trying to look at ancient knowledge, trying to look at it with a scientific lens of today, and assessing it whether it can work in today's world. Yeah, so that is again another interesting research that we have to our name. And we also did the first use case on quantum key distribution back in 2018. So we were amongst the first SIs to actually try out something in quantum security. Yeah, so that's just to kind of give you a glimpse of where we come from. As a lab, we are present across the world. Our mothership is in Pune. So I would like to invite all of you to Hinjawadi campus of ours and visit our lab. We work in 4 major areas, which is AI, IoT robotics, quantum computing, and metaverse. So with that small introduction, I'll get into the topic of today. So if you look at AI surge, right, it's been a surge, isn't it? None of the board meetings or board discussions are complete without the topic of ChatGPT and what can ChatGPT do for us. So although generative AI has been around for some time, right now is where we see a lot of surge in the demand. We have seen a lot of use cases. We also do applied research. So we have done that for a lot of clients to see how we could use ChatGPT or similar large language models for using in real life scenarios. There's also the spend. So from a business angle, everyone is ready to spend and try to see how generative AI can be useful for them. But then there is an eco strain, right? So right now, in the excitement of what AI is able to do for us, probably we have not yet looked at the eco strain that this is causing. And also there is a precision pivot. So you see those large language models with billions of parameters. So the sizes are also quite huge. Do we really need that large models for the work that we wanted to do? Yeah, so that is a question all our customers and all different forums we have started discussing today. Now, if you see the carbon footprint of how much we are spending when we are trying to train the models, it is actually 57 times more than what an average human would spend in a year. right? So whenever we are training these large language models, we are actually spending a lot of, or rather we are having a large carbon footprint. And if you look, if you say that, okay, see, one company is actually making this large language model and everyone else is using it, so what's the big deal? Actually, you are reducing the cost of AI. But that is not the case, because even if you see the statistics of how much of carbon footprint is getting generated when we are using those large language models, that has also grown quite a lot. So overall, this entire thing, this race about creating billions and billions of parameters today in those large language models may not really be the way forward when we look at this aspect. Moreover, there is a big gap that is being created. So on the green line, you would see that these are all the hardware infrastructure that we are having available today. And the other red line you see, these are all the models, starting with GPT-1 BERT, it goes on to the models that we see today, and the kind of infrastructure needs that they have got, right? So this is a big gap again, where the rate at which infrastructure is growing and the rate at which the models are growing, that is also quite huge. And then that also brings us back to that question about, do we really need these huge models? So that is where, from our side, we are trying to address this problem in a multi-pronged approach. So the first approach is about engineering. Whenever we are building these generative AI models, right, or rather using them for any kind of real-life use cases, how do we really make sure that it is being used optimally? And that is the engineering excellence that we are bringing to the fore, which consists of a combination of discriminative and generative AI. So this is where we are creating different pipelines to make sure that whatever usage of AI we do, it is done to the minimum level, it is done to the optimum level, I would say, not minimum. Plus, we are looking at refined text for fine-tuned models. So what is happening today, I mean, many of you would have tried to implement these generative AI models. So what happens is you pick up that model and you fine-tune it with your data. So in that, we are trying to approach it with less is more kind of way, so that refined text is being used for fine-tuning of the models. So this is on the execution excellence part. So how do we really make it executed in such a way that we address these problems that I talked about? Secondly, we are also looking at the compression techniques. So if you see, suppose you all have seen the ChatGPT, it is generating those answers for you. But some of you might have tried implementing other models like, say, Llama or Falcon or other things. And what happens is, these models are very huge, so it needs a lot of infrastructure. And also, it takes a lot of time to generate the response. We are all talking about language here. So what happens is, it takes, in fact, sometimes up to a minute to generate a response, which is not acceptable. So these two things are getting addressed by compression techniques. There are compression techniques called pruning, sparsity, and quantization. I know the time is less today, so I will not get into details, but these are techniques which we have tried and benchmarked as well. And we are able to see a lot of difference when you're using these compression techniques in two aspects. One is the amount of infrastructure you need to implement this kind of a solution, as well as the speed at which you can get responses. Yeah? So this is another thing that we have experimented and found, and we are using in our solutions. Now, beyond this, I mean, that is the topic, right? These are the things of today. What is generative AI doing? How people are using it? What is the best way to use that generative AI? Is still all today. But what next? Is this path of generative AI really sustainable? Yeah, and that is where we are looking at alternative architectures. And I'll talk a little bit more about that, whether it is the neuroscience-inspired AI, as well as the quantum-inspired techniques. So just to summarize on this slide, basically, one is, we are looking at the large language models. An alternative, can we have a medium-sized model which is built for a particular purpose, which we are doing, I'll talk about that, as well as compression and alternative architectures. So now let's look at something very interesting. We all know that neural networks, or the AI that is built on basically neural networks, it mimics the neuron of the brain. But is it able to really do something that humans are able to do? Right? What do we do today when we are doing so many things? We are explaining and understanding what we see, right? At the moment I'm explaining things to you, is by understanding things as well, you are also understanding something While doing that, you're also probably imagining something that has triggered a memory in your head, which when I was speaking about certain things. Even while doing that, you could be planning to solve some things, right? In your brain, so many different things are going on at the same time, whereas whatever has been achieved by AI today is only doing a small bit of it, which is generating language, right? And this is where the difference is. That is the neuron and how the neural network is based on the neuron, but there are 2 or 3 things that the brain does, which a neural network does not do. For example, we have a memory. The neural network doesn't really have a memory, right? We have a temporal memory, in the sense we are able to make sense of time. That's not what the model does. And the third thing is we have an ability to forget. This is very important when it comes to managing the kind of things a human does with the 22 watts of energy that we use, right? That's a major part, and that's not there. That's the reason why all of these models are becoming so huge. Right? So that is where we are looking at studying the brain and actually coming up with a different way of doing AI, which is not necessarily related to neural networks. So that is our topic of research. This again, if you look at the language, yeah, through the lens of the language, actually it's just a medium of communication, isn't it? We are saying something, I'm saying something, it may mean different things to different people. So it's not an exact science, right? And that is what this cartoon really says. It's very intriguing when we are trying to generate language by AI, which is not really understanding. It's all brute force that has been used to train these models. It is just generating words which probably can make sense to humans. So that is also another challenge when it comes to natural language processing, right? So I'll just now go back and tell you about what are the things that we are doing. So the one, if you remember, I was talking about the building smaller models, building the models which are purpose-driven. So this is a project we have started, which is called the Indus project. This is kind of a civilizational initiative, we say, because in India, see, what happens is maybe 10 or 15% of the people would be speaking English as a language. And everything we have got in technology is all English. All the large language models are doing English. If we want to get this kind of language or natural language processing and this kind of AI successful in India, it will happen in the hinterlands only when we speak their language. So we have decided to pick up Hindi as our language. Yeah, and of course in India, if you see, there are 27 official languages, 1645 dialects, which are registered dialects, but if you count each and every language which changes every 100 kilometers you go in India, someone has counted it as said that there are 19,000 languages, including all dialects, if we count all dialects. So that's an impossible problem to solve. Having said that, we have decided to pick up Hindi and 40 of its dialect to create our own LLM from scratch. So here the vision is to use it in certain areas. One is agriculture, second is rural finance, and the third area is healthcare. So these are 3 major areas where you need to provide services in the hinterland. We are starting with rural finance, but then we are also going to have fine-tuned models for the other areas as well. So we have actually gathered data of Hindi and its 40 dialects from various different sources. We are in the process of model building at the moment, and within the next couple of months, you should see the large language model for India, which can understand the dialects as well, coming up from the Makers Lab. Now, the second point was about learning from the brain, right? So one was about the very, very large language models and do we really need them? So here is what we are trying to build. We are trying to gain the experience through creating this model. And of course, the Indus project is open source, so it will be available for everyone. The second thing is, what are the alternative architectures that we can think of? Learning from the brain, what can I make out of it? And this is where this is a patent pending solution that we are building. It is called the SGN or Synaptic Graph Language. So it is actually making this kind of network of words. Yeah? So the things that I was talking about, having a memory, having the ability to forget, right? These things are actually built into this way of doing AI. This is still kind of in progress, but just wanted to give you all a glimpse as to how we are thinking and how we are trying to implement it as a solution, which is a completely different approach than what AI in the world is happening today. Yeah, so this is where so it's based on the concept of how a young child would learn anything. So if you see when a very young child, when they're starting to learn language, you teach them A for apple, say for example. So the moment you say A, they are going to repeat A for apple, A for apple. That gets ingrained in the memory because it is used multiple times. Whereas if after you grow up, you don't associate A only with apple. You associate A with multiple different things. So the weightage of that A to apple slowly goes on decreasing and the other words start coming into our mind. That's a similar model that we are trying to implement in this kind of a solution. Yeah. Now, beyond this, so we talked about large language models, what kind of things we can do by making those models smaller, either through engineering excellence or through building our own models. And we also looked at an alternative to how AI can be made. Beyond that, if you go, today what is happening is the world of quantum computing is now coming to the fore. People have different opinions, right from it's 2 years away to 10 years away, but we believe that it is very much here and now. There are a lot of advances in the way the quantum computers are being built. And it's not, people have brought certain computers even to the room temperature, which are possible to use at room temperature. The kind of errors that you are getting in quantum computers are also going down drastically. Number of qubits have also started increasing. So we believe that quantum computing is at a stage within a year or so, we will start seeing some very good operational use cases in quantum computing as well. So that is certain thing which is very important, and that is why it is a big area of focus within our Makers Lab. And how we are looking at quantum, so 2 or 3 major areas, right? One is the quantum-based security. Probably that is the first one that is hitting the markets, where we are looking at, first of all, quantum-safe algorithms, right? So today, security is all based on RSA. Everyone knows that can be broken using quantum computers in a few seconds, which is unbreakable today because of the kind of infrastructure and calculations it needs. But with quantum computers, it can be broken. It's a big risk to everyone, the entire network and the data that we have across the world. So the moment any organization declares that they have done this, it will be a frenzy of people trying to implement quantum-based security. In the US, you would have read about the NIST algorithms or quantum-safe algorithms for security that people have started implementing now. And those are the things that our clients are also looking at. How can we safeguard our network, our data centers from quantum attacks? So that is one area of focus we have experimented on all of these NIST algorithms. We are able to do that. And I was talking about quantum key distribution in the beginning, where we have actually implemented quantum-based security. So with BT, which is our long-time client and partner, they laid down a fiber, which was a 200-kilometer fiber between Cambridge and one of their research labs, and then we were able to actually encrypt it using quantum. So quantum security is one area, and then the second area is the optimization and machine learning. So quantum machine learning is another area of focus, which is coming up very soon now. We believe that, going with the topic of generative AI and language, we believe that quantum NLP is something to look forward to in the coming days and months. And that is something that will come out very soon. So beyond AI, if you look at it, we see that quantum-based solution for all those problems which are very difficult as of today, that are going to come to the fore. So yeah, there are multiple opportunities across verticals. I know the time is short, so I'll not go through all of them, yeah. But I'll just say that a lot of different customers and partners have started looking into it. There are many startups across the world, a lot of them also in India, who have come up and are doing amazing work in this area. And so I think that's, I'll just skip a few of those slides, but basically, just to summarize, I think it's an exciting time in the technology world, as it always is, I guess. But then these are some step changes we are seeing, and we are very hopeful and very excited to see how the future unfolds. Thank you.
Thank you, ma'am, for that very insightful session. I felt like I was looking at some Mission Impossible script or something like that, all the stuff that was on the stage. Right, so how many of you remember the name that I spread for the topic? Anybody here? There's a prize if you do. Okay. All right. So Gen AI advances, pitfalls, and what's beyond neural networks. All right, ma'am, we're going to felicitate you. So just be on stage. Can I invite Mr. Shrikant to please come on the stage and felicitate ma'am? All right. Thank you, ma'am.